Hello, we are discussing about GATE 2004 ECE paper, and the topic we are discussing is electron devices. This is 8th 2-mark question, came in GATE 2004. Assuming that the beta of the transistor is extremely large and VBE is 0.7 volts, then IC and VCE in the circuit shown are. Look at the circuit. For that circuit, beta was given. It is very large and VBE is given as 0.7 volts. Then IC and VCE as indicated in the circuit diagram. This is IC and it is VCE. What will be the values of IC and VCE? A. IC is 1 milliampere, VCE is 4.7 volts. B. IC is 0.5 milliamperes, VCE is 3.75 volts. C. IC 1 milliampere, VCE 2.5 volts. IC, that is collector current, is 0.5 milliamperes, VCE is 3.9 volts. Out of the options, the correct one is C. IC is equal to 1 milliampere and VCE is equal to 2.5 volts for the given diagram. We will see the details now. This is a given diagram. So this diagram is nothing but it is self-biasing circuit, and NPN transistor power supply is 5 volts and the other side is grounded. RC is 2.2 kilo ohms. RE is 300 ohms. And R1, R2 are going to be given. R1 is 4 kilo ohms, R2 is 1 kilo ohm. VBE is given and beta is very large. We need to calculate IC and VCE, collector current and collector to emitter voltage. This is very important. When beta is given as large, that implies nothing but simply you can neglect the base current. Why? How? IB is equal to, how do we calculate IB? IC by beta. Whereas beta is very large, so IC by very large is nothing but you are going to get it as very small. That very small can be neglected, so IB is equal to 0. Simply whenever beta is very large is given in the question, any question, at that time you can neglect the base current. Whenever base current is neglected, the important conclusion is collector current is nothing but emitter current. So IC is equal to IE. So same current which is flowing through 2.2 kilo ohms, it is also flowing through 300 ohms. That is the meaning. So if you calculate current flowing through 300 ohms, that is nothing but current flowing through 2.2 kilo ohms, which is nothing but IC. So since it is self-bias, first you have to draw the Thevenin's equivalent at the base side. So base side circuit diagram is going to be replaced with Thevenin's equivalent, that is nothing but Thevenin's voltage with Thevenin's resistor circuit. So this is a circuit. Simply base side has been replaced with a Thevenin's voltage and a Thevenin's resistance, where the values of these two things, RTH is nothing but R1 parallel R2, that is 4 kilo ohm parallel 1 kilo ohm. So it is equal to 1 kilo ohm parallel 4 kilo ohms. Next, VTH is nothing but voltage at base to ground, that is nothing but voltage across 1 kilo ohm resistor. As the current flowing through base is 0, entire current from 5 volts, it is going through 4 kilo ohm and 1 kilo ohm only. So that you can use a voltage divider rule to calculate voltage across 1 kilo ohm, which is nothing but threshold voltage. So VTH is equal to 1 kilo ohm into 5 by 4 into 4 plus 1. So it is equal to 1 volt. Threshold voltage is 1 volt and Thevenin's resistance is 0.8 kilo ohms. So calculate IC, that is nothing but IE itself, because IB is equal to 0. Calculate IE from base emitter loop. So apply KVL across base emitter loop, which is nothing but over here, VTH minus IB into RTH minus VBE minus IE into 300 ohms. But IB is equal to 0 because beta is very large. So we can neglect the voltage drop across this Thevenin's resistance. IB into RTH will become 0 since IB is 0. So that simply the KVL will be consisting of VTH minus VBE minus IE into 300. From this one you can calculate IE. IE is equal to 1 minus 0.7 divided by 300. So that is 1 milliampere. and since beta is very large, IE is nothing but IC, so IC is equal to 1 milliampere. Next, to calculate VCE, apply KVL across collector emitter loop. Apply KVL across collector emitter loop to calculate VCE. So this will be consisting of 5 volts minus 2.2 into IC minus VCE minus IE into 300 ohms. This is KVL for the collector emitter loop. From this one, substitute the known values. Plus 5 minus IC is 1 milliampere and IE is also 1 milliampere. The unknown parameter is only VCE. That VCE can be solved, and this will be equal to 2.5 volts. So IC calculated is 1 milliampere, VCE calculated is 2.5 volts. The correct answer for the given question is C. Thank you.